three. Stage is yours.
Cool. So hey guys, my name is Mitesh Mistry. I'm a Salesforce CTA and I head up our architecture practice at VRP Consulting. So firstly, Amit, thank you for giving me the chance to present. I feel it's always nice to share your knowledge in the Salesforce community. We've all been through different experiences, different places we've worked. And it's kind of nice to dispel that knowledge amongst the different community members out there and get everyone up to speed on the Salesforce platform as well. So thanks for giving me that opportunity. Before we begin, so a few words about me. So I don't have much of a Scottish accent, but I did grow up in Scotland. I studied software engineering, like probably a lot of people, at the University of Edinburgh. And then I started work in the consulting space. So I started working as a graduate at Deloitte in London, worked there for 2 years, then worked at a few smaller consultancies from there, Acumen Solutions, Cloud Sherpas. They were then bought by Accenture. So I felt it was the right time to work at the mothership. So I spent 3 years as a technical architect and senior program architect at Salesforce before joining my current place, which is a Belarusian-based Salesforce Platinum partner, VRP Consulting, where I head up our architecture division. So that's the career stuff, but something I do have to say is that I was on a TV show, which Amit was mentioning, so the Family Cooking Showdown. If you guys have Netflix, search for Family Cooking Showdown Season 2, and episode 8 onwards, you will see us there. So something to watch in your spare time. And the last thing I mentioned is I'm a Salesforce CTA, passed in May 2018. And I felt that the journey of learning to achieve the CTA was a really good one. And I highly encourage and recommend everyone to pursue that path. And, you know, if you don't, it's not about clearing the exam, in my opinion. It's actually about the learning which you gain throughout the process, because the things you pick up on across the different domains in Salesforce is what you will use day to day as an architect. And I think that's what the really important thing is about the program as a whole. So today I thought we'd have a session which can cover two bases. Firstly, I want to speak about large data volumes in Salesforce, how we manage those, and also give you a bit of grounding for the data architecture exam, which they have in Salesforce as well. So I'll go through the following bits. We'll talk about LDV, how do you define it, what challenges can it cause, how do you manage data on the Salesforce platform if the data has to reside there, what are some common considerations to keep in mind, how does LDV impact sharing, something which you should consider, how do we go about migrating or loading data into Salesforce, and what's the right strategies for doing so, and then lastly, a few words about our techniques as to how we can manage data which needs to be archived or kept off platform, and how we can go about doing that as well. So firstly, let's start by talking about why is LDV important. So in my mind, I typically define LDV as being any object in Salesforce which has greater than 1 million records. I think in those situations, you need to think about the impact that'll have on certain areas of the Salesforce platform. Where does it impact? Well, basically the blue box is here. So when you're running reports and dashboards, if they're running over a large data volume, they may take a little bit of time to load up if they're not structured correctly. Secondly, we've got our SQL queries. If they're having to query across a large data set, depending on how your query is written and what is indexed in Salesforce, they may become suboptimal, which might mean that a Lightning component based on a SQL query may suddenly slow down. List views, which may not be using skinny tables or custom indexes, their performance may slow down as well with large volumes. We also need to consider other areas. So ownership skews. This is typically situations where we've got more than 10,000 records being owned by a single user in Salesforce for a certain object. That can cause you certain challenges when you start moving people around the role hierarchy. So that's stuff to think about. Record locking, that can happen in conjunction with data migration. When you're trying to load above 10,000 records in, which are tied to the same, let's say, account or tied to the same contact, you could start having some issues when loading data. And also the last thing I'll say is sharing calculations. So if you're changing record ownership, which does have an impact on sharing, it can mean that those sharing calculations can take longer to run. So it's something else to keep in mind as well in terms of LDV and where it can impact. So before we dive in, I think it's important to start by mentioning just under the hood, how is Salesforce structured? How does Salesforce store our metadata? And how does Salesforce store our data? So firstly, in the Salesforce platform, we have a metadata table, which basically describes our custom objects and fields. So that's under the hood how Salesforce stores it. We then also have our data table, which actually contains the physical records in the org. There's a virtualization layer, which then combines the data and the metadata to show the UI to the user in Salesforce. So kind of what you're seeing when you open up Salesforce and you're opening up an account, for example, is a combination of the metadata table and the data table to surface an account record on screen to you as a user. So this also leads me to the question of saying, well, what about SQL? How does that work? So when we take SQL, which a user provides, under the hood, because Salesforce stores it in kind of SQL style of databases, it gets converted to native SQL, and Salesforce performs the relevant joins to be able to fetch the data in an optimal format for the user. So there's a couple of things that happen underneath the scenes when we fire off a SQL request. Now, moving on from that, it's worth talking about how does search work then. So each record, when you create a new record in Salesforce, it takes about 15 minutes roughly to be indexed after it's created. So you might find the searches may not necessarily return something straight away, but after 15 minutes, it'll be in place to make sure it comes back. Salesforce, where it can, will use the indexes to find the records which are there. When Salesforce finds the rows of data, based on security predicates, so this is basically saying, in terms of a sharing perspective, what rows of data do you have access to? You can filter that down, which then forms the result set for the user. And this is kind of an important point that always use with sharing in your Apex classes to make sure this form of result set is formed. And once result set reaches a certain size to what Salesforce believes you need, the additional records are then taken out. They're not leveraged at that point. So this is then used to fetch the records for the user. Now, the system that drives this and controls what kind of table joins to do, what's the optimal path to use, what indexes we should leverage in Salesforce, it's done by something called the Salesforce Query Optimizer. There's something to look into to understand how it works behind the scenes. Now, a few techniques we can use in Salesforce to speed up the means and speed and efficiency with which rows of data get returned to the user. So the first thing I typically talk about is skinny tables. So firstly, what is a skinny table? Well, to speak about it, we should firstly understand how Salesforce stores data for standard and custom fields. So in Salesforce, data for standard fields, things like your last modified date, things like your account name, the standard fields, it's stored in a separate table. Your custom field data is stored in a separate database table as well. If you ever run a query or a report or a list view, which is combining standard and custom fields, Salesforce has to do a join together and then surface that data back to the user. So that's typically how it works with how things are stored. Now, as you can imagine, that means querying two tables. It can be a bit slower, right? So if you want to speed up how your queries perform, you can implement something called a skinny table. And what that's doing is you are saying, you look at your query and think about what are the fields which I want to really commonly access in my query. You maybe have a handful of standard fields, a handful of custom fields. You can then request Salesforce to create a skinny table for you, which then combines these standard and custom fields together. And when you run that query, which can then leverage that skinny table, what you'll find is because it's a condensed table, you can have your rows of data returned a lot quicker for the user. And the second thing I'll mention is that it doesn't contain soft deleted records. So if you've marked a record which is in your Salesforce recycle bin, normally a normal SQL query would actually be querying those as well. Whereas if you use a skinny table, those do not get returned. So this is kind of another use case for why skinny tables should be used. So if you look at this diagram at the bottom here, you can kind of get the understanding where in a single database fetch, if you're querying a large number of fields, which is using a standard table, it takes longer for the query to go through that and return that in a single set. Whereas if you've got a narrower table, you can return more rows of data in a single fetch through using a skinny table. So if you have LDV use cases and you're using a combination of standard and custom fields, but your typical reports or list views or SQL queries are leveraging the same kind of fields, and you've got large volume, definitely contact Salesforce to enable a skinny table on that particular object. It'll help making your queries a lot more performant. So that's strategy number one for an on-platform management approach. The second strategy I'll mention is around indexing. So in traditional database speak, what is actually an index? We should talk about that first. So an index is basically a sorted column on a certain field or a combination of columns which can uniquely identify a certain or particular row of data. The way the index works is that it's a sorted column and it contains a pointer to the specific rows of data. So if you look at the column here on the left-hand side where we've got a sorted index, If someone runs a query on the comp number field, which you can see here, and you say, right, give me all the rows between 10, where comp number is greater than 10 and less than 20, then you can see, because the index field is sorted, it's very easy for it to quickly go through that data, find the rows that you need, and return them. If you didn't have the index, you'd need to probably do a full table scan, because something with a comp number of 12 might be at the very end of the database as a more recent record, and you'd have to do a full table scan to get that data back. So what we're avoiding by using an index is having Salesforce to run a full table scan to get rows of data. Now, there's two types of indexes which are there. So on certain fields, Salesforce creates a standard index for you. These are the following: the record type ID, division, created date, last modified date, name, email. If you have a lookup or a master detail, that's also referenced as an index, the Salesforce record ID, an external ID, and unique fields. So these are the standard Salesforce fields that typically get created as a standard index. So what that means is, if you're to have a SQL query being run, and you, in your where clause, you're saying where, let's say, created date is greater than this date, Salesforce can use a standard index to quickly get that data back for you. Now, you obviously will be working on projects where you're creating custom fields. So we can create custom indexes for our custom fields as well. You can create them for most of the field types, apart from the following. You cannot create them for multi-pick list, currency, long text, or binary fields. They can be done for what we call deterministic formula fields. So these are ones where you can easily identify data. And then the last thing I'll mention is, you can't create custom indexes for columns which may have null values in them. So for standard index, it's there by default. For custom indexes, you contact Salesforce to enable them. You can also have a 2-column index. So if you have one column which is not great at uniquely identifying rows of data, you may want to have a joint index where you've got 2 columns which combined together can uniquely identify data. The way that can work is where one column would select the records to kind of filter on, and the other column would be used to then sort that particular data. So that's where you can have a 2-column index as well. Now, with indexing, there are some things to keep in mind, and it's worth discussing how the query optimizer leverages indexes in Salesforce. So firstly, we spoke briefly about the Force.com query optimizer, and that determines what Salesforce index we wish to use. With standard index fields, let's say we've got an LDV table. If a query filter matches less than 30% of the first million records, then we can leverage that index. So if you have a standard index, if a query can filter less than 30% of the first million rows, we can say that, yes, it's a deterministic index. Let's try and use it. With custom indexes, it's a bit more restrictive. You need the filter to match less than 10% of the overall records, up to a maximum of 333 records. So that's how the filter criteria works for custom index fields. So Salesforce determines the percentage of records which are likely to be returned when evaluating whether an index should be leveraged or not. And I think the last point I mentioned, which is similar, is we define a query as being selective if either a standard or custom index can be used based on the number of rows that are going to be returned from the overall data set using that particular query. So a few kind of pointers here. You can improve the performance of your SQL queries when you have at least one, but if you have 2 or more filters in the where clause which allow the query to meet these conditions, it can let an index be used. Salesforce also checks for queries which are frequently run, and it can create an index for you if that's going to increase query performance as well. So if you've got a query which, let's say, is being fired from a Lightning component, that component runs by all the users daily, Salesforce can look to then create an index for you in those situations. And then finally, similar to my point before, where the query optimizer, it'll decide what indexes to use, can we avoid the table scan, what necessary joins should we make to optimize our query execution. So that's the job of the Salesforce query optimizer. Now, what are typical best practices that we should use when leveraging indexes? So wherever you can, in your where clauses of your queries, leverage index fields where possible. Avoid trying to use the where clause on columns which have null values present, because an index cannot be used in that case. If you're writing a query, so you have select and then your fields from this object, the fields you're searching for, do not firstly query anything which you don't need, and use fields which would be present in a skinny table, which means it actually can be used. Use filters which you feel can kind of segregate or highlight less than 10% of the data. Avoid using wildcards in your query searches, such as the percentage symbol. It prevents the index from being used. If you have multiple complex queries which may not let an index be used, you can actually break them down into singular queries on a single entity, and then programmatically join the data together. That might allow you to actually use queries with indexes. So that's another implementation thing to keep in mind. And then lastly, which is I think a kind of 101 pointer for Salesforce, is when you're writing SOAP queries, do not have all the fields there in your response. Just keep in the SOAP queries the fields that you actually need. It's basic stuff, but it's something which is worth mentioning over here. So that's spoken about indexes and skinny tables. And these are approaches that typically we would use to manage data on the Salesforce platform. For those who have got aspirations for sitting the CTA review board, if you're thinking about large data volume and you've got an object which has to sit in Salesforce, so for example, a bank which deals with 5 million customers, those account records have to be in Salesforce. So you then need to come up with an on-platform approach for managing those. And typically I would then look at, can we use a skinny table? Can we implement a custom index so that the data can safely sit in Salesforce, but we're not going to slow down the performance of our queries, of our reports, of our dashboards, list views, etc. So something to keep in mind over there. So let's now move into talking about some data level considerations. So the very first one we should think about is ownership skew. What is ownership skew? This is where you have more than 10,000 records in a single object that are owned by a single owner. So 10,000 records, one object owned by a single owner. Sounds reasonable. Why would this actually cause us a problem? So the problems happen in the following use cases. So when you start moving a user to a different spot in the role hierarchy, the sharing calculations need to then take place over those 10,000 records, right? And then we need to determine based on that how access rights are changing for other users in the hierarchy for a larger volume of records. If this person only owned a lower number, so let's say 100, 500, whatever, you would not have such a complex or a long-lasting calculation taking place. Now, when you move people around in the role hierarchy, you're causing the sharing rules to be recalculated for both that particular user in the hierarchy when he's being shifted, but also for any users who are now going to be above that user in the role hierarchy as well, because they're going to get access to that particular record. So this is kind of, in a very nutshell, I'm summarizing this, but it's worth you guys thinking about how the group and group member tables work to store role memberships in Salesforce. That'll bring it to light exactly how this works. Now, for ownership skew, how do we avoid the situation? So the kind of strategies typically to keep in mind are, firstly, data migration. So when you're doing data migration, try where you can to divide records up across multiple end users. Sometimes what we find is when we're doing starting a project, we may have an admin user or the integration user, and they own all the records because they were migrated in like that from that particular user. It's not good practice to do it. So always try and divide up where you can. Maybe if you got users across different regions, then you can divide up accordingly that ways. Have a think about those things when loading data. Leverage where you can lead and case assignment rules. So for ongoing data management, and we're creating leads and cases, use assignment rules to make sure they get assigned out to appropriate users and ownership's managed that way. And then if this is unavoidable, then another strategy that we should keep in mind, it does actually come into play, is try to have an isolated role at the top of the role hierarchy for that user. And what that actually does is it makes sure that the sharing calculations don't need to take place for that particular user at the very top of the hierarchy, because there's nobody above him in any role. So it's one of the techniques to keep in mind if you need to do an integration user-based use case. That's ownership skew. The second area we should look at is parenting skew. So in parenting skew, when you have more than 10,000 records for a single object underneath the same parent record. So let's say we have an account and we have more than 10,000 contacts underneath that account. This is an example of a record parenting skew. Where can this cause an issue? So imagine we're loading data into Salesforce. We're loading a mass volume of contacts, and we've got, let's say, 15,000 contacts which are against the same account record. We're using bulk API as an example. So what may happen is if you've got records in one batch in bulk API coming in and records in another batch coming in, and let's say parallel processing is enabled, you may have two contact records getting updated in Salesforce, which are linked to the same parent. And that might cause a record locking in place when you've got two separate threads of execution trying to update two contacts which are tied to the same account because the account inherently updates as well. This is where problems can occur at this point. So the other area that gets impacted is something called implicit sharing. So where you have access to a parent record driven by access to children. So you may have rules in place which say, if I can access the contact, I can access the account as well. So what happens when you lose access to a contact, or that's how your sharing is set up. So when you lose access to a particular contact, Salesforce now needs to know that do you still need to have access to the account that the contact was linked to or not. And if you have over 11,000 contacts linked to that account, you need to check each one to understand if there's any other contact that you have access to, which would implicitly grant you access to the account as well. So implicit sharing takes a hit in this kind of scenario as well. So the rule of thumb and how you should avoid this is avoid having more than 10,000 records of a single object linked to the same parent record, if you can avoid it. If you have free hanging contacts which need to be tied to, let's say, accounts, and there's no account them for them, try and create multiple kind of holding accounts against which less than 10,000 records of a contact can be placed. And then the other thing which we can also do is, this is more, not necessarily to do with accounts, but just a general point. If you are having an object which is looking up to another object, and the object which you're looking up to has only got 3 or 4 records, you may want to use a pick list field instead. In those kind of use cases, perhaps having a record that you look up to maybe doesn't make sense. So in this case, a pick list field might be a better option to avoid it here. So we've spoken a little bit about ownership and parenting skew. I think it's worth now diving a little bit into sharing considerations as it flows on nicely from what we're talking about. So when we're looking about setting up sharing properly in Salesforce, I typically look to follow this kind of decision tree. And I highly recommend you guys take a picture of this because it's a good tree format to use when looking at how to set up our org-wide defaults in Salesforce. So for a particular object that we're setting up sharing for, the very first thing to ask is, who is the most restricted user of this object? So if we're dealing with accounts, who is the most restricted user who's going to have access to accounts? Is there ever going to be an instance of this object that the user should not be allowed to see? So are there any accounts in the account table which this restricted user should not be allowed to see? Okay, if there is, then we know that we need to make the sharing model as private. We cannot do it public read only, it needs to be private. If there is not, then we need to ask the question, is there any instance of this object, any records, which the user should not be allowed to write? If he is going to be allowed to write to everything as well, then it becomes public read only, public read write. But if there are going to be certain records which he is not going to be allowed to write to, then you would create your sharing model as public read only. This is a very nice decision tree, but it just shows you how you should go about thinking and defining your org-wide defaults for your core object which you have in Salesforce. As a general best practice, wherever you can, set your org-wide defaults to public read write or public read only for access to non-confidential data. Reduce the requirement for a share table by having these org-wide defaults in place. And for when you're modeling object relationships, if it's possible to have it as a master detail, considering how the sharing works for that child record, use control by parent where you can, because that avoids another share table being created in Salesforce. So whenever you're thinking about org-wide defaults, I know a lot of projects where this kind of discussion ends up happening very late. We think about sharing, but think about it early on when you're defining your data model, thinking about who's going to own records, thinking about how they're going to be shared, who's going to access what. Think about that early on at the data modeling point and not kind of last in a project. This is something kind of key to keep in mind. Now, this leads me on to talk about two kind of sharing calculation approaches. So when you're dealing with large volumes of data, sharing calculations can take time. And what are some techniques we can use to speed up the pace at which sharing calculations can be done, or do them so that they can be done later after we've applied all the sharing updates you want to do? So let's talk about two techniques. So firstly, parallel sharing rule recalculation. So sharing rules, they're typically processed synchronously when role hierarchy updates are made. So it's done like one and then the next and the next and the next one after the other. Sharing rules can be processed asynchronously, and they can be split into multiple execution threads. So a single sharing rule can then be executed across parallel threads. And that's what parallel sharing recalculation lets you do, where you take a sharing rule, it can be processed across multiple threads, which means the sharing calculation can be finished a lot quicker. So if you need to do this, you need to ask Salesforce to enable parallel sharing recalculation for you. The next piece is around deferred sharing rule calculation. So what we do here is we make our role hierarchy updates, sharing rule changes, and group membership changes, do all this stuff which you need to do it up front. At this point, we are actually turning off the calculation of sharing rules. So share table calculations across all objects are deferred. Once all your amendments and updates are complete, we then re-enable our sharing calculations to take place. In order to do this, you need to contact Salesforce to enable this functionality. Again, it's something which they have to enable for you. It's good practice to test this process in a sandbox environment first, and then verify the results and timings, how long is it taking to do an action, etc. What I also suggest is when you're doing this kind of data update, sharing calculation, determine a window with the customer when they are happy for us to have a bit of downtime. It may be a Friday evening, might be a weekend, and then apply your deferred sharing rule calculation. So we basically turn things off at that point, do our updates, and then turn it back on to allow for the rules to be recalculated. So it's good to do that outside of business hours to minimize impact on a client org. And the last one is granular locking. So when you are performing updates to our roles or groups tables, which is stored as group and group member behind the scenes, the entire group membership table is locked to ensure that data remains correct and to preserve data integrity. So when you're doing multiple updates like at the same time to roles and groups, it may cause a degree of locking to take place whilst one change, let's say, is being processed. So the system, when this is enabled, granular locking, it allows multiple updates to proceed simultaneously if there's no hierarchical or other relationship between the roles or groups involved. So what this means is if you enable granular locking, we do two changes which are not going to impact each other or they're not related, we can allow those changes to take place, and that can be done with granular locking. So what this means is groups which may be in separate hierarchies in a role hierarchy, you may be able to modify them concurrently because they will not impact each other. And this is where the term granular locking comes into play. So moving on now, we've talked about kind of sharing techniques, how we go about managing sharing in the Salesforce platform, how we apply rules, how we can defer sharing calculations. The next step, and I guess the next thing that does come to mind is, okay, well, we need to now load data. So what are the kind of right techniques for doing so? So in my mind, I typically pictured a data migration to follow this kind of pattern and approach. So this I break down typically in a 4-step process. We firstly want to configure your org to be ready for a data load. So the kind of things you should do is you want to enable parallel sharing rule and deferred sharing rule recalculation. You want to now create your role hierarchy and load users, get all your org-wide defaults set up initially as public read write, because what that means is there's no shared table that needs to be maintained for those particular records when they're going to be brought in. And also an important point, disabling workforce triggers, process builder, and validation rules. The next step is to then prepare the data which you want to bring in. So firstly, you should identify what data you want to load into your new Salesforce org. It may be last year's worth of data, last 5 years worth of data. What does it actually need? So you should first identify that initially. We then want to extract, cleanse, enrich, and transform the data to create a golden record. So we've got data coming in from, let's say, SAP or some other systems which need to be deduplicated and cleansed. It's a very typical use case. We want to get that ready in a target state format so that it's ready to load into Salesforce. We've cleansed out all the duplicates. We've merged records together when necessary, and the data is in the right form to load into the Salesforce platform. So this is basically a data cleansing or transformation job. Typically use an ETL tool to perform this kind of operation. And when you have the data prepared, the very first thing to do is to then test out the load in a sandbox first. Usually you'd have a performance testing sandbox, which you enable. It may be your pre-production environment, post UAT. That kind of environment, which would usually be a full copy sandbox, you can then use to do a data load test as well to see how that works and what issues you encounter at that point. The third step is obviously to execute the load. So the kind of techniques to follow are loading parent objects before loading children. You want to then extract the parent keys for later loading of the child data. Use insert and update commands instead of upsert. Interesting point, but apparently the upsert operation firstly validates the data based on the object's ID, which means that the upsert takes a little bit longer to run than an insert or an update operation. So something to keep in mind if you very well know which operation you're going to be doing at that point. If you're doing a data update, only send in the fields whose values have changed rather than trying to send in the whole bulk of fields as part of the process. Group the records with parent ID when using the bulk API. So we spoke earlier about record locking and having two separate batches which both contain records which may link to the same parent. Avoid that. So in that case, sort your data first, group it by parent ID. So all the records which are tied to the same parent are in the same batch file going up into Salesforce, which prevents a lock conflict from happening. That's a good technique to use. And if you are dealing with a use case with more than 50K records, then in the interest of speed, performance, time for execution, leverage the bulk API where you can. The last point here is around configuring your org for your final data load. So what I would do is firstly, while the loads are happening, I would ensure that we have deferred our sharing calculations at that point. We want to get all our data in and then have the sharing calculations run afterwards. We want them to be paused. We now, once the data is in, you want to change the org-wide defaults from public read write back to public read only or private once things are complete. So now the sharing rules can then run. At this point, it's now time to enable or configure our sharing rules to be executed. So you can create them one at a time, and that allows your sharing rules to then run once these are in place. Or if deferred sharing is there, then create all your sharing rules now, and then we enable the sharing calculations to run. We then enable our triggers, workflows, and validation rules. And then lastly, we create a roll-up summary fields in our production environment. So this, I feel, is a really kind of comprehensive, but a good step-by-step process you guys can follow when doing a data migration with a large volume of data into the Salesforce platform. So that's some approaches. Let's now talk about off-platform. So how do you manage data which is going to be not on, but off the Salesforce platform? So firstly, what are the typical use cases, or when should we look to archive data in Salesforce? So firstly, we only want to keep data which is going to be currently accessed by our user group in the Salesforce platform, or we may have some regulatory requirements which require us to keep data in Salesforce. So only keep data in Salesforce, which really needs to be there. Records which are more than, let's say, 4 or 5 years old, which customers are either archived, they're no longer trading with us. It's best practice to try and get them off the Salesforce platform and store them in your operational data store or data warehouse or some other system. And what this will do, it keeps your data relevant, but it also improves the performance of your reports, dashboards, and list views, because your SQL queries that run need to then run over a smaller data set. Your list views that run or reports that run need to go through a much smaller set of data if you have only current data kept in the Salesforce platform. We should archive data for compliance purposes, so we may be required legally to keep the last 10 years of data. European GDPR laws or some other countries may have laws in place in these situations. To maintain a backup of your data is another core use case for archiving. And then the point which I've been mentioning is around performance, to ensure that redundant data is not impacting your performance in Salesforce. So on those grounds, what are some approaches we can use to archive data from Salesforce? So one approach is leveraging a middleware tool such as MuleSoft or Jitterbit. And the way we do this is follows. So firstly, in Jitterbit, we should maintain for each object the date at which the last extraction was run. And you can call that a last job run for that particular object. So we've got two here, last job run account, last job run contact. We use the bulk API to make a request into Salesforce to run a SQL query to give us all the records that were modified since the job last ran. Now, interestingly enough, just keep in mind I've used system mod stamp here. And I've used system mod stamp because in Salesforce, when automated processes in Salesforce run to update a record, the last modified field may not change in Salesforce. It's predominantly a user-driven field. So the system mod stamp field, however, is always updated, and it may be more recent than the last modified date field. So therefore, it's good practice to use a system mod stamp field where you can when submitting a bulk API request. So we firstly fire off this request to get the data. We then may want to divide the data into batches to be then written to our enterprise data warehouse. And obviously in our middleware tool, we'll define our source and target mappings. Step 3, we then write our data into our enterprise data warehouse. And then lastly, step 4, we then have to update our last job run date. So we then say, right, the job last ran at this date and this time. So the next time we pull Salesforce, we'll only pull for records which were modified after this job last ran. Another approach which is starting to gain a bit of traction. So for customers who have Heroku and Heroku Connect in place, connecting into the Salesforce org, we can certainly leverage Heroku as part of a data backup and archival service as well. So here's how it can work. So firstly, we have tables which are connected with Salesforce, which are our Heroku Connect tables. And we can have stored procedures which maybe take data from our Connect tables and store them into archive tables to basically take them off the Salesforce platform. We can also have archive and unarchive calls, so we can perform web service calls, which you can invoke from Salesforce to archive data from our Connect tables into our archive tables. And then for data which is held in our archive tables, we can use Lightning Connect or the OData 2.0 API to show our data, our archive data inside of the Salesforce platform. So this is a nice framework that we can use when Heroku is in place to be able to store data off the Salesforce platform, but in a very kind of usable, viewable, and easily implementable manner. So a good pattern that we can use. We also have Salesforce big objects. So I've not really used these too much in Anger myself. I think it's certainly a good technology that Salesforce have in place. So with big objects, what we can do, we can have an Apex trigger or a batch process to insert a record into a big object in Salesforce. It could be coming in from an external system, parsing a CSV file, or directly a Salesforce one. We can leverage the bulk API to extract data into a CSV file and use a middleware tool to load it into Salesforce, or we could use a SOAP API to load the data into Salesforce big objects. So there's a few different means we can use to actually create a big object records in Salesforce. Now, where can big objects be shown or viewed or used? So firstly, in SOQL, we can use our SOQL queries to query big object data, but this is only usable when you have a low volume of data which is going to be returned to the user. So in these cases, you can use a SOQL query. If you're going to be querying larger volumes of data, it's better practice to write async SOQL. And when that async SOQL runs, you're creating a job which is going to write that record into a custom object, very similar to like a reporting snapshot. You're going to write the data in a custom object via an HTTP post request, and then that data in the object can be leveraged in the Salesforce report or somewhere in the UI. So these are two different means of accessing data which is stored in Salesforce big objects. And the very last technique or approach we can use is a market-based tool. So we could leverage something like Own Backup or Odasiva to look at data backup and archiving options in the Salesforce platform. So these are some industry tools that we can look at for larger volume, more enterprise use cases as well. So that's it from me. I've run through a few areas of kind of backup techniques, archival techniques, and how to manage large data volumes in Salesforce and the impact it has on the Salesforce platform as well. So I'm ready now to open the floor up to any questions which you guys may have, and it'll be good to have a discussion on some points.
Thank you, Nitish. So I can see lots of questions into the chat window. Would you like to read or you want me to read? So
okay, let me bring it up as well so I can see them here. Okay, let's slow this is scrolling quickly. Let's scroll down. So okay, so the first question is around how do we deal with list view loading impact? So we spoke earlier about skinny tables, which combine together your standard and custom fields. So the fields or columns that you display in the list view, firstly, make them minimal. Do not have extra stuff there, but only choose columns to be shown in the list view, which you know for sure are present in the skinny table. That'll let the list view then leverage the skinny table when surfacing the data for the user. Secondly, if you're implementing a filter on the list view, then filter on a column which you know for sure is being created as a standard or custom index in Salesforce, which will then also allow that to be used and for the list view results to be returned quicker for the user. Okay, so the next question is skinny table similar to temporary table? No, it's not a temporary table. It's something that Salesforce will maintain. It's not a custom object in its own right, but you contact Salesforce to enable that skinny table for you, and it's maintained in Salesforce at that point. Do skinny tables come at an extra cost? Not that I'm aware of. I haven't personally used them myself or asked Salesforce to do it, but as far as I understand, I don't believe there's any additional license fee to have that in place. Do you need to write logic to sync the skinny table to the standard and custom fields? No. So when you create a skinny table in Salesforce and new records are being created, they're automatically populated into the skinny table as well. So behind the scenes, Salesforce takes care of that for you. Nothing which you need to write especially to do that. How do we deal with scenarios where the columns require changes time to time, and how do you get the structure of skinny tables customized? So this one, you need to contact Salesforce to get those changed when necessary. Okay, good, someone's answered that. Which one is a better option to improve performance, custom index or skinny table? Okay, so I think that's down to how many fields are you needing to query. So for example, if you know that you only need to mostly query 6 or 7 fields, and your reports, your list views, your dashboards, your SQL queries are only normally wanting to have these 7 fields be returned, then use a skinny table. If you have a large volume of data and we want to then quickly search that data, and there's, let's say, a handful of fields, I'm going to say 1 or 2, that can be used typically to filter that data, then you would leverage a custom or standard index to do so. So I can't say they are considered separately. I would think of them as being used together, the indexes and the skinny tables. When you say that Salesforce does checks for frequently used queries to create indexes, is that on an org by org basis and only on tables with LDVs? No, so it is per org, yes. Salesforce would, on an org basis, have a look at what queries are being frequently run to determine what indexes to apply. Is it only on tables with LDV? So my honest answer is that to that one, I'm not sure, but I would expect that they would focus their efforts on tables which have a certain threshold of records in place. Okay. The answer to that one is no. So the question here is ownership skew. Does it matter if the isolated role at the top has got multiple users? No. Any users which are going to be in a situation where they have got or are going to own a large volume of records, then you can put them at a single role at the very top of the role hierarchy. I don't think it matters that there's 2 or 3 users there at that point. What's the next one? Yep, you answered that. Okay, so there's a question about ownership skew. So rather than a top level role being used, will it be the same effect to leave the role blank? Are there any drawbacks to leaving it blank? So yeah, that's another approach that gets taken too. I've seen a lot of orgs where the admin user is not assigned a role. So that is something else we can take as well. But typically from a data security perspective, you would normally have a role allocated to a user. And in those scenarios, you need to give them some role, which is in some position in the hierarchy. So you could choose that approach where no role is assigned. Maybe for like an integration user, that's okay. But for any user which is going to be governed by sharing, you would then look to assign them a role at the top of the hierarchy. So no drawbacks really, apart from the sharing impact and the sharing consideration. How to fix parenting skew after it has been created. So parenting skew, just to recap, was where we had more than 10,000 records which are linked to the same parent. You can look at a few things. So let's say you've got an org structure where we've got an account representing a global company, but they may have child accounts as to how they operate. Underneath those child accounts, some contacts can be assigned. So you might want to consider using an account hierarchy instead to fix the parenting skew situation. That's kind of one technique you can use to resolve that issue. Lookup relationships can be made safe for parenting skew if the lookup is soft. I clear the right if this field is selected. If it does not, okay, that's fine. Okay, next question is, for parallel sharing rule recalculation, is there any downtime for users suggested, or can it be executed by users using the system and creating records? So this is an interesting one, and I would base it on data volume. So if we're doing any kind of sharing rule update, and it's on a table which has got a large volume of records, it's going to be done outside of business hours. So in terms of downtime, I would suggest it be done kind of nightly once the users have gone home, they're not using the system. At that point, you'd look to leverage these kind of calculations. Next question is how to easily disable workflows, triggers, PB validation rules, and flows. So very good question here. And for workflows, PB validation rules, there's a few ways of doing it. I'll go with triggers first. So in triggers, you can actually put implement your triggers which look up either custom settings or custom metadata. And the custom metadata may just simply be a table that says trigger name enabled or not, trigger name enabled or not. It'll go into that first to check if the trigger is on. If it's on, then let it run. If it's off, do not let it run. So I've seen that as a new approach a lot of people are taking now to actually quickly using custom metadata or custom settings, enable and disable triggers. In terms of workflows, I've disabled them mostly by hand, but you may want to look at any form of either profile permission set or custom permission-based assignment to disabling these areas as well for standard functionality. Okay, how to find old records to archive. So old records to archive, I would say you would look at last modified date on that record and say, when was that record last touched? And a record which may have been last touched, let's say 5 years ago, may no longer be relevant. However, think about the child records as well. So you may have an account, you may have opportunity underneath that. You may have records which are children, which may be more frequently updated than the parent one. So think about the entire nested structure of data when looking at what you need to archive at that point in time. So next question is, when determining data for archiving, is it needed to check for the check objects created by Salesforce internally? No, I would say no. I probably haven't answered the question, but my answer is probably a no on that one. On approach 1, bulk API requests, is it query and then a delete later? Okay, so we had approach 1. Let me go back. I can go back on this one. And let me bring up the chat again. Sorry. Yes, you're correct. So once the data is archived and taken off platform, yeah, you would then look to remove that data, which let's say may no longer be required. If you're doing a full kind of archival process, then yes. When using external objects, any major limitations that you have to keep in mind? So there's limits to the number of records which can be queried, which are held in an external object table. So it's around, there's a number there which Salesforce have in terms of how many you can query. There's also reporting impact as well when data is held in external objects. So there's some good links in the Salesforce documentation that walk you through the limits for external objects. So worth checking those out. What else do we have? Okay, for CTA review board, are we supposed to recommend an on-platform solution first? The answer to that is definitely no. So my personal take on the review board is, if you're in a large data volume scenario, which you're considering, then transactional data typically would be off platform. Now, if the transactional data is 100,000 records, it's wrong for you to say that should be off platform. But if your transactional data, the table that's got the highest volume of records, if that specific one looks like it's more than 1 million rows, I'd then start to look at off-platform approaches, which could be either using Heroku, storing that in a company's own data store, and using something like OData to store that in Salesforce. The best use case I can think of is a bank situation where you may have 5 million customers. Each customer may have, let's say, 20, 30 transactions. All of a sudden, you're talking 100 million rows. You wouldn't store that in Salesforce. So those situations, the account table, yes, keep that in Salesforce by all means, even though it's still LDV. The transaction table should be totally off platform in that situation. So think of it in that sense when looking at what to store on platform, what to store off platform. So big objects, what determines SOQL versus async SOQL? So that's down to you really. So if you are going to be returning a large volume of data back, then async SOQL is your way to go. If it's going to be a selective set of data going to be returned, then use normal SOQL. That's what I would answer to that one. Do we need to consider audited call-out rate limits when recommending external objects? I would say yes. Just think about against the records that they're going to be bringing up, how many rows are we going to surface back? Worth considering. Key considerations when deciding on platform versus off platform. I think I've spoken about that just now. Last piece, is Salesforce LDV preferred over the solutions, big object, Heroku, ETL based solution? So interesting question. Like, you know, I've painted different options here. I don't think we obviously have got different approaches we can use, but a lot depends on what the customer has. So some customers may have a data warehouse, and then you can say, right, and they have middleware in place. And then you tell them, let's build it this way. If they let's say are having an ETL in place, then definitely leverage that. If they don't have anything and you want to start fresh, Heroku can be a recommendation. So just think about what their landscape looks like and what you feel as a customer they'll be able to take on from a technology point of view. So that's how I would look to those kind of things. So a few more questions coming in. Let's have a look. So does platform encryption affect off-platform data store synchronization encryption? So Shield platform encryption does a certain degree of data encryption. I would think the answer is yes. I'm not an expert in Salesforce Shield, but I would expect there would be some impact there. With the LDV bank example, you just gave about off-platform transaction. What if you need to do stuff with the data? I assume you mean something like connect with the data system in Salesforce. So yeah, so with the bank example, we were talking about transaction data. And transaction data, if we wanted to interact with that data from Salesforce, then yes, certainly Salesforce Connect can be used to then update that data on the external system. And typically, I give a good use case here where we're dealing with a retail customer and they had their customer data in Salesforce, but they had the transaction data, which they're doing in store or online, held off platform. We're using OData to surface that transaction data in Salesforce. And if we had to either view it, do something with it, whatever, maybe you need to update it for whatever reason, we're able to do that directly from the Salesforce UI using OData. So that's a good use case for OData, and Salesforce Connect can be used. The other thing I'll mention is if your target system does not support Salesforce Connect, we can't use it with that system. It doesn't have an OData adapter, but it is REST enabled. You can actually build your own custom OData adapter using Apex and Salesforce, which will behind the scenes make REST API calls out to that third-party service to get data. So that's a way you can mimic an OData service from Salesforce, where OData may not be supported by the particular data store. So let's look at some more questions. What have we got here? After data is moved to off-platform to view data. Well, to be honest, you've got either option. If you can use OData, great. I think in a review board scenario, I'd probably recommend OData first because we don't think about cost. But in the real world, most customers probably don't want to pay for it. So you would then look to build API services to make those calls. Are there any steps which can be taken if data migration has impacted your components like triggers, flows, which are part of average change package or so can be directly controlled? Yeah, so if you know what those triggers are trying to do in those packages, try to get your data ready in the target state format so that if the triggers had run, what would they be checking for? What conditions do they check for to run on those records? Get into the target state so that they don't actually need to run. That's the approach I would take in that situation. Okay, cool. And someone just messaged me on LinkedIn. Yeah, so find me on LinkedIn. Just search my name. You'll see me there. I'm wearing my chef's apron, so it won't be difficult to find. Cool. So that's very whirlwind.
Our audience as well. So we will share the recording of this session on our Apex Hour YouTube channel, and I will be highly recommended everyone to follow our Apex Hour website to get the notification for upcoming session and presentation. So lots of people ask me like share the presentation and recording. So definitely it will be available just after the session. And thank you so much for everyone for the joining us. Don't forget to subscribe our YouTube channel and follow our Apex Hour website for upcoming sessions.